Hi students, in this video we are going to look at Venn diagrams and how to use them to display the outcomes of some experiment and use those to work out the probability of events happening. Right, so after watching this video you should be able to use Venn diagrams to display the outcomes of two or more events, and then use Venn diagrams and the data that's in them to calculate probabilities. Some things you'll have to remember. So remember how to calculate experimental probability. So that's the number of favorable outcomes over the number of trials. Or put another way, the probability of event A happening is the number of times that A happens divided by the number in our sample space, or our number of possible outcomes. So that, remember, that could also be given as n psi, which is this sort of letter here. Now, the other thing to recall is our set notation, so including the language and symbols for intersections and unions. All right, Venn diagrams are a useful way to represent the outcome of two or more events. So let's say we've got two events that are A and B. So we'll say this circle is A and this circle is B. And each region in our Venn diagram represents some number or aspect of our probability distribution here. So in the middle here, we've got our intersection. So here we've got our intersection of A and B. And in our Venn diagram, you can see that's where the two circles intersect. That's region in here is where you'll find elements that are in both A and B. On this side here, on the left, that's where we'll find the things that are A only, or that can be written as the intersection of A and not B in this region here. On the right side, in our blue circle, that will be B only, so things that are not A but are B. So the intersection of things that are not A but they are B. Finally, our fourth region is on the outside here, and this is where we find things that are neither A or B. Or we can write that as the things that are not A and, well, the intersection of things that are not A and not B. If we're looking at our union, A and A or B, we'd be looking at our whole region inside our circles. So this section here, all of the things inside A or B, that would be our union. All right, so let's do an example with some Venn diagrams. From a group of 30 people, there are 10 of them that like eating pepperoni pizza and 15 that like eating Hawaiian pizzas. 4 people like both. Now the first thing we have to do is express this information in a Venn diagram. So we've got our diagrams here, and let's label our circles. This left-hand circle could be the people who like pepperoni. This right-hand circle can be the people who like Hawaiian. Now, where to start with a Venn diagram? Usually you want to start with the numbers you know. And in particular, you want to start off with intersections. So start off with intersections as much as possible. So in our question here, we're told that we've got 4 people that like both Hawaiian and pepperoni pizzas. So that's our intersection. That's our intersection of P and H there. So in our overlap section here, we can say that there are 4 people who like pepperoni and Hawaiian. From there, we can start filling in the rest of our gaps. We know in the P circle, in the pepperoni circle, there must be 10 people. Right? So there must be 10 people in the pepperoni circle. We've got 4 already in the pepperoni circle. So in this extra outside part, there must be 6, right? Because 10 people in this pepperoni circle, subtract 4 that are already there, we've got 6 to the left. In the same way, in the Hawaiian part of our circle, we know there are 15 people in that Hawaiian circle. We've got 4 already, so there must be 11 people who only like Hawaiian, so that the total of that Hawaiian circle ends up being 15. Now, what about people who like neither? Right? We have to always consider that there's some people who might not like either. So altogether, people who like pepperoni or Hawaiian, right? That's our union, pepperoni or Hawaiian. We've got 6 plus 4 is 10, plus another 11, 21 people like pepperoni or Hawaiian pizzas. Now in our question, there was a survey of 30 people. So that means if we take away the 21 that are in the circle, inside our union, there are 9 people who are left who don't like pepperoni and who also don't like Hawaiian pizzas. And there's our Venn diagram. All right, looking at our next question, state the number of students who enjoy only pepperoni pizzas. Well, looking at our Venn diagram, that's this number here. So the people who like pepperoni only, so the number of people who like P only, right? It's not the intersection. Those people like pepperoni and Hawaiian. The people who only like pepperoni will be outside of that intersection. So that's 6. Now, calculate the probability that a random person, randomly selected student, likes either pepperoni or Hawaiian pizzas. Well, we've already found out that someone likes pepperoni or Hawaiian. We found out that number above. It was 21. So the probability that someone likes pepperoni or Hawaiian, that's our union, is our number of people who like pepperoni or Hawaiian out of the number of people in our sample space. So the number of people who like pepperoni or Hawaiian, we just added up those numbers, 6, 4, and 11, gave us 21. Out of, there's 30 people who are surveyed. Then we can simplify that. That's 7 out of 10, or 70%. There's a 70% chance that randomly selecting another student or another person out of that group, there's a 70% chance that they will like either pepperoni or Hawaiian. Right, so after watching this video, you should be able to use Venn diagrams to display the outcomes of 2 or more events, and then use Venn diagrams to calculate those probabilities. We did that in our second example there.